We're going to look at section 2.5 in pre-calculus. This is page 14 of your packet, and we're going to continue to find zeros and to write polynomial functions if you are given some of your zeros. We're going to look at the fundamental theorem of algebra. All right, first of all, we also have the linear factorization theorem, and it says if f of x is a polynomial with a degree n where n is greater than 0, then f has precisely n factors. And we've already established this. Your degree tells you how many solutions or how many factors your polynomial is going to have. And then you can write your expressions like this: x minus each of these zeros, x minus c sub 1, x minus c sub 2, and so on. Your C1, C2, C3, and C to the n here, those just represent your possibly real solutions or complex numbers, because we may find that we have some imaginary solutions. All right, so here we go. We've got, here's our polynomial, f of x. The degree is 5. We've got 5 zeros. We're going to go ahead and look at Descartes' rule of signs and try to determine how many solutions we have. This 0 means that if one of your solutions is equal to 0, that's where that category is, that's where it's going to fall. All right, so we've got change of signs. If I go through my polynomial without doing anything to it, I've got 1, 2 changes of signs, so I could have 2 positive or 0 positive. Now when I go through and I change by finding f of negative x, if I do f of negative x, I'm going to have a negative. Here I would also have a negative. I'd remain positive. This would become positive, and the 8 remains positive. So here I have just one change of sign. Now what that tells me is it tells me that I may have one negative solution. So if I have 2 positive, 1 negative, then I would have to have 2 imaginary, or maybe a 0. If I've got no positive and 1 negative, then that would force me to have 4 0 or imaginary solutions. So they have to add to 5 going across there. That's how that Descartes' rule works. Now let's find the p over q's. So I've got plus and minus the factors of 8, which are 1, 2, 4, and 8. And that's it, because the q values over q is just the factors of 1. So there's my p over q's. The next thing that we're going to do is we're going to synthetically divide and see if we can find any of our solutions. So let's start off by trying to do, let's just do synthetic division with 1. I've got 1, 1, 2. Let's go back here. We got to insert some zeros. Got 1, power of 4 would be 0, power 3, power of 2. Negative 12, and then 8. So synthetically dividing, 1, and you add, multiply, add, multiply, add. I'm going to keep going all the way through here, and hopefully, oh, it looks like I am going to get a remainder of 0. So what that tells me is I at least have 1, and 1 is a positive real solution. It's positive real. All right. Something else that you can do is continue to synthetically divide. I've got a power of 5 here, and I go down here to a power of 4, and it does not give me any indication that I'd be able to factor by grouping or factor this yet. It's not a quadratic, so we just have to come up with some other values. Okay, now if I have 2 positive or 1 negative and 2 imaginary, I've already found one of the positive, which means I also have a negative. Maybe what we do is we try another number in our list here. Let's try negative 2. Bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and I actually get another remainder of 0. Okay, so I've got 2 solutions. so far. It is leaving me down to this polynomial x to the third minus x squared plus 4x minus 4. It can factor. I can group these and take out an x squared, and you get x minus 1. Here I'm going to take out a plus 4, and I get x minus 1. Final factoring is x minus 1 and an x squared plus 4. This concludes my other solutions are another 1. So I've got 1, 1, negative 2. And if I solve x squared plus 4, x squared plus 4, and set it equal to 0, then x squared would equal negative 4. And so x would equal plus and minus 2i, plus minus 2i. That would give me all 5 of my solutions. Some things that you have to do is you might have to do your synthetic division several times here before being able to find the ones that work. Okay, that's your final result. You can see here I've got that multiplicity at 1. All right, here's some other information that's important. An nth degree polynomial will have precisely n zeros, real and complex, all together. And the complex zeros always come in pairs because they're plus and minus the square root of something, so they always will come in pairs. All right, another thing that we're going to look at is taking a polynomial or the zeros of a polynomial here, and we're going to write and find a 4th degree polynomial. So we need 4 zeros or 4 factors. We need 1, 2, 3, 4 factors. One of them is going to be x plus 1. The second one would also be x plus 1. When I have 3i, not only do I have 3i, but I have a negative 3i for one of our solutions. So we do x plus 3i and x minus 3i. You write the expression. And what we're going to do now is FOIL. So let's go ahead and put the first two together. When we put the first two together, we're going to get x squared plus x in the middle would be 2x, and then plus 1. When we square the second two, we get x squared. The middle terms cancel, and then we'd have minus 9i squared, which ends up being plus 9. And the last step would be to distribute all of this out. So our function f of x will equal, I've got x squared times x squared, which is x to the 4th, x squared times 9, which is 9x squared, 2x times x squared is 2x to the 3rd, 2x times 9 is 18x, and then 1 times each of those, x squared and plus 9. Like terms are, so final answer, f of x equals x to the 4th plus 2x to the 3rd (10x squared) and last 18x and our plus 9. That's your polynomial. It has a degree of 4. We took all 4 solutions and wrote our expression. All right, let's try another one. Find a 3rd degree polynomial function with real coefficients given the zeros of 2 and negative 4 plus I. If negative 4 plus I is a 0, so is negative 4 minus I. That is also a 0. We've got x minus 2. We've got x minus 4 plus I, and the other one would be x minus 4 minus I. If you go and write your x minus the zeros, you would get both of those expressions. Now what we're going to do is I'm going to combine the second two so that we can get rid of our imaginary units. So I'm going to leave the x minus 2 alone for a second. And I'm going to FOIL all these together. X squared minus 4x minus xi, negative 4 times all three, negative 4x plus 16, and then plus 4i. And then we got 3 more. xi, so plus xi, minus 4i, and negative I times positive I is negative I squared, which is plus 1. All right, I'm going to go ahead and add all my like terms together. I'm going to have, let's go ahead and look to see what I can cancel. We can cancel our xi. We can cancel our 4i. It looks like that's it. So I've got x squared. I've got minus 4x and a minus 4x. If I go back here, R0, I think I've dropped off this negative here. So when you do x minus a negative 4, both of these would be positive. And all that's really going to affect at this point is my positive 4x, my positive 4x, and it's still plus 16, but that would give us plus 8x. So I had to go back and adjust a couple signs because of the minus. That's 4x. You got plus 16, and plus the 1 is 17, plus 17. All right, now last step would be to distribute the last two expressions. So my function f of x equals, you've got x times x to the third, or x to the second, which is x to the third, plus 8x squared, plus 17x, minus 2x squared, minus 16x, and then minus 34. So final answer, you got x to the third. I have a total of 6x squared, 17x minus 16x is plus x, and then minus 34. There's your polynomial if you are given the 3 zeros there that you have. All right, that is it. We've got one more problem, and what I would like you to do is pause the video. Okay, pause the video here. I'm going to go ahead and get you set up, and then I'm going to see if you can get through the rest of this one. You've got, here's your original polynomial. You're given one of the zeros is 1 plus 3i. Okay, so you would do x minus 1 plus 3i. And then you would do x minus 1 plus a negative, or minus 3i. We're going to FOIL this, multiply it all out. And then what you're going to do is you're going to take what you have and do some long division and see what factors you have left. All right, so go ahead and FOIL this out, do long division and see what you have, and see if you can find the rest of the zeros. And then I'll go ahead and perform it for you. All right, so here's what we've got. You're going to take your expressions right here. You FOIL it all out and multiply, and you get your polynomial x squared minus 2x plus 10. So that means this is one of the factors of the original. If you do long division, then you would be able to divide your polynomial by its factor and get another factor. And x squared minus x minus 6, and we had a remainder here of 0, then that also factors into x minus 3 and x plus 2. So this gives us our other two zeros. Our final result, your zeros are 1 plus 3i and 1 minus 3i, the 3, and the negative 2. So that's all 4 of your zeros. Here is your assignment for section 5.